Hey, welcome to my channel. In this video, you will learn the basics of Firebase Cloud Firestore. Cloud Firestore is a flexible and scalable database for mobile and web and server development from Firebase and Google Cloud Platform. Like Firebase Realtime database, it keeps your data in sync across client apps through real-time listeners and offers offline support for mobile and web, so you can build responsive apps that work regardless of network latency or internet connectivity. So, basically Firebase Cloud Firestore is quite similar to Firebase Realtime database, but armed with more advanced features. Therefore, it's usually used for apps that are heavy on data storage that require faster and richer queries. You can find a full comparison between the two solutions at the link in the description below. Data in Firebase Cloud Firestore is stored in a form of collection and documents. A collection in Firebase Cloud Firestore holds multiple documents. Each of these documents holds data in different types. It could be bytes, booleans, date and time, floats, arrays, numbers, strings, geographical points, maps, or other collections, aka subcollections, that in their own turn hold another set of documents that hold data and so on. In JavaScript, we use the collection method to get the location of a specified collection, and we use the doc method to get the location of a document. So, enough talking, and let's get started by creating a project in a database. Okay, now that done, we need to create an app to get the configuration code so we can use the different Cloud Firestore's functions in our project. Make sure to not forget to add the Firestore library, because without it, nothing will work. First off, let's create a constant that will hold the different Cloud Firestore functions that we need to interact with the database. So, to save data in the database, we need to specify the reference to where exactly we want to add the data. Then, call the set method, which should have an object as parameter. This object holds the different information we want to save. Since I'll be using the users collection a lot during this tutorial, I store it in a constant for less repetitive, cleaner, and more organized code. Now, let's say we want to add data to a document. If we use set, all the previous data will be overwritten. Therefore, to prevent the old data loss, we need to add another parameter to the set method, which is an object that has the merge property that we need to set to true. So now the admin field will be added without deleting the other fields. Up until now, we have been hard-coding the document's identifiers. However, if we want them to be automatically generated, we can use the add method instead of set. Another way of generating IDs automatically is to store an identifier in a constant, then use it later calling the set method on it. To update data, we should simply specify the document's reference and use the update method, which takes an object that holds the new data as parameter. We can get rid of then and catch since they are optional. Updating an object is a bit tricky. If you thought that we could just specify the name of the field and set the new property, well, that's wrong and I'll show you why later. So, the right way of updating an object is to specify the name of the object, followed by a dot, then the name of the property. Now, if we use the other way that we talked about earlier, all of the properties of the object will be overwritten. Updating arrays is also quite different, as there are certain pre-built functions to use in order to update this type of data. So, to add data to an array, we should use the array union function. To delete data from an array, we should use the array remove function. There's also a useful function that allows us to get the timestamp of when the data got updated on the server, which is the server timestamp function. We can increment and decrement numeric values using the increment function. In order to delete a field from within a document, we should use the delete function. Deleting a document is also pretty easy. We just need to specify the document's location and then use the delete method. To read data from the database, we need to use the get method on the reference of a document. The exists property informs about the existence of the document because the non-existence of a document doesn't count as an error. Now, to get the data of all the users, we need to use the get method directly on the users collection, which holds the different documents. To query a database based on a field's value as criterion, we need to use the where method, which is similar to the where clause in SQL databases. Let's say I want to query the database based on the value of the last name field. Then I should use the where method. The first parameter should contain the field's key. The second one is the querying operator. And finally, the third one is the value we want to query based on. Arrays, on the other hand, have special operators. So, to get documents that have a certain value in a field that must be an array, we should use the array contains operator. We can also get documents that have a value or more among other values that we specify in another array. In this example, if a user has C, PHP, Java, Delphi, or C++ in their favorite languages field, they should be selected. An important thing to mention is that arrays that are set for the comparison can take any more than 10 values to search for. We can chain multiple queries. However, the fields of the query must be the same. As you can see in this example, I used the age field as a criterion in both of the where methods. Finally, to get the data from subcollections of all the documents, we need to use the collection group method and then use the where method as usual. The query doesn't work because we need to set an index for such a query, which is beyond the scope of this tutorial. To set the index, just click on the link provided in the console and everything will be handled automatically. Now, as you can see, we got every document that has museum as type from the landmarks subcollection, which is nested in every document in the cities collection. Same as Firebase Realtime database, we can attach listeners to the references in the database, so whenever an event happens, a callback function gets triggered to execute whatever code you put inside of it. Furthermore, we can attach listeners to more than a single document using the where method. We can also get the type of the event that occurred on the reference using the type property for each document found by the where method. The doc changes here is a method that returns an array. This array contains the list of the changes that occurred on the document. Finally, we can add a second parameter to the snapshot method to debug or handle errors that might occur while listening to the data changes. There's way more advanced stuff to learn about Firebase Cloud Firestore, such as accessing data offline, transaction and batched writes, indexes, and much more, so make sure to check the documentation on their official website. And this should be enough for this tutorial. Make sure to subscribe and hit the bell notification, and see you in the next one.